Our second learning target during week 8. I can observe and describe the minerals found in rocks. I can do this by looking at the various physical characteristics such as shape, color, luster, texture, hardness. Minerals can be identified by color, luster, streak, cleavage or fracture, hardness, density, and other special properties. Let's take a look at color first. Color is the least useful way to identify minerals because the same mineral can be many different colors. For example, pure quartz is clear, but if there are any impurities in the quartz, it can be many different colors. Luster. Mineral luster describes the way a mineral surface looks when light reflects on its surface. There's metallic luster, submetallic luster, and non-metallic lusters. Here are some examples of metallic lusters, including things like, from left to right, galena, pyrite, magnetite, and some varieties of hematite. Submetallic lusters includes things like this sample of hematite, which is less shiny than the sample seen above. Non-metallic lusters include things that are vitreous or glassy, like quartz and tourmaline, in the top two pictures. Resinous looks like a resin or like plastic, including sulfur and sulfurite in the next two pictures. Pearly non-metallic lusters include things like talc, greasy include things like graphite, and they have like a thin layer of oil on them, or at least they look like it. Silky include things like gypsum and malachite. Gypsum is the white one next to the bottom, and the malachite is the greenish swirled one next to the bottom. And then on the bottom are 3 examples of adamantine. They have brilliant luster and sometimes colors flashing in the mineral. Best example, most common example is diamond, but there's also clear lead like cerussite and anglesite. Streak testing. The color of a mineral in powdered form is called the mineral's streak test. The mineral streak of hematite is always red-brown. The streak is not affected by air or water, so a streak test is better than a color test of a mineral. Cleavage is when a mineral breaks along smooth, flat surfaces. Mica and halite are good examples of cleavage. Meanwhile, fracture is the way minerals break along curved, irregular shapes and surfaces. These samples of obsidian show fractures known as conchoidal fractures. Native Americans used their knowledge of these types of fractures to fashion arrowheads. Mineral hardness is its resistance to being scratched. Hardness is on a scale of 1 to 10, with 10 being the hardest minerals. Density is the amount of matter in a given amount of space. In other words, density is the ratio of mass to the volume of a substance. A ping pong ball and a golf ball both take up the same amount of space, but a golf ball is much heavier due to its density. There's more mass in the golf ball. The density of water is 1 gram per cubic centimeter. Water is the standard we use to measure other substances. The ratio of an object's density to the density of water is known as its specific gravity. Gold has a specific gravity of 19. That is to say that gold is 19 times the density of water, or 19 grams per cubic centimeter. That's why the miners were able to find gold by swishing it around in water. It was the thing that stayed in the bottom of the pan. There are some special properties of minerals. For example, fluorescence. Under ultraviolet light or black lights, some materials glow with fluorescent colors. These materials can come from all different places. Exotic places like Mexico or Morocco or Canada, or places people have never even heard of like Utah. They come from all over the world. So, learning target number 2, I can observe and describe the minerals found in rocks, and I can use their physical attributes such as shape, color, luster, texture, and hardness. If you can do that, you're welcome to move on. Otherwise, feel free to go back and check the video again so that you know how to describe minerals found in rocks.